Simple Digit Recognition OCR and OpenCV-Python. I am trying to implement a digit recognition OCR in OpenCV-Python, CV2. It is just for learning purposes. I would like to learn both nearest and SVM features in OpenCV. I have 100 samples, i.e. images, of each digit. I would like to train with them. There's a sample letter underscore recog.py that comes with OpenCV sample. But I still couldn't figure out on how to use it. I don't understand what are the samples, responses etc. Also, it loads a text file at first, which I didn't understand first. Later on searching a little bit, I could find a letter underscore recognition.data and CPP samples. I used it and made a code for CV2.nearest in the model of letter underscore recog.py, just for testing. It gave me an array of size 20,000. I don't understand what it is. Questions. 1. What is letter underscore recognition.data file? How to build that file from my own dataset? 2. What does results.raval denote? 3. How we can write a simple digit recognition tool using letter underscore recognition.data file, either nearest or SVM?
Well, I decided to work out myself on my question to solve the above problem. What I wanted is to implement a simple OCR using nearest or SVM features in OpenCV. And below is what I did and how. It is just for learning how to use nearest for simple OCR purposes. 1. My first question was about letter underscore recognition.data file that comes with OpenCV samples. I wanted to know what is inside that file. It contains a letter, along with 16 features of that letter. And this soft helped me to find it. These 16 features are explained in the paper letter recognition using Holland-style adaptive classifiers. Although I didn't understand some of the features at the end. 2. Since I knew, without understanding all those features, it is difficult to do that method. I tried some other papers, but all were a little difficult for a beginner. So I just decided to take all the pixel values as my features. I was not worried about accuracy or performance, I just wanted it to work, at least with the least accuracy. I took the below image for my training data. I know the amount of training data is less. But, since all letters are of the same font and size, I decided to try on this. To prepare the data for training, I made a small code in OpenCV. It does the following things. It loads the image, selects the digits, obviously by contour finding and applying constraints on area and height of letters to avoid false detections. Draws the bounding rectangle around one letter and wait for, key press manually. This time we press the digit key ourselves corresponding to the letter in the box. Once the corresponding digit key is pressed, it resizes this box to 10 by 10 and saves all 100 pixel values in an array, here, samples, and corresponding manually entered digit in another array here, responses. Then save both the arrays in separate .text files. At the end of the manual classification of digits, all the digits in the training data, train.png, are labeled manually by ourselves. Image will look like below. Below is the code I used for the above purpose, of course, not so clean. Now we enter into training and testing part. For the testing part, I used the below image, which has the same type of letters I used for the training phase. For training we do as follows. Load the .text files we already saved earlier, create an instance of the classifier we are using, it is nearest in this case, then we use nearest.train function to train the data. For testing purposes, we do as follows. We load the image used for testing, process the image as earlier and extract each digit using contour methods, draw a bounding box for it, then resize it to 10 by 10, and store its pixel values in an array as done earlier. Then we use nearest.find_nearest function to find the nearest item to the one we gave. If lucky, it recognizes the correct digit. I included last two steps, training and testing, in single code below. And it worked. Below is the result I got. Here it worked with 100% accuracy. I assume this is because all the digits are of the same kind and the same size. But anyway, this is a good start to go for beginners, I hope so.
For those who interested in C++ code can refer below code. Thanks Abid Rahman for the nice explanation. The procedure is same as above, but the contour finding uses only first hierarchy level contour, so that the algorithm uses only outer contour for each digit. Code for creating sample and label data. Code for training and testing. Result. In the result, the dot in the first line is detected as 8 and we haven't trained for dot. Also, I am considering every contour in first hierarchy level as the sample input. User can avoid it by computing the area.
I had some problems to generate the training data.
because it was hard sometimes to identify the last selected letter, so I rotated the image 1.5 degrees. Now each character is selected in order and the test still shows a 100% accuracy rate after training. Here is the code. For sample data, I made some changes to the script, like this.